Hey there. In this lecture, we're going to study about data visualization in Python. Visualizing your dataset is the most important and I guess the most crucial part in exploratory data analysis. Whenever we want to explore and visualize our data. So in a sense, you can say that no one wants to read tons of paper describing your dataset. Mostly you want to, if there is a better way to visualize it, if there's figures or you can say plots that you can visually interpret the information that you can through words, it is much preferred, especially when you're giving presentations or creating prototypes or demos. So data visualization helps you, as well as whenever you want to, you can say, interpret and comprehend the information available and to make it understand and comprehensible to other people as well. So what is data visualization? By the formal definition, it is the discipline of trying to understand data by placing a visual context. So in a way, we can understand the patterns, trends, and correlations that might not be detected otherwise, because there are some sort of information that are way easy to grasp if you're visualizing them. Especially such trends or correlations that are hard to interpret by just looking at the numbers. In this way, you can interpret and combine different data and you can visualize them to identify patterns in it. So Python provides us with excellent libraries for graphing information. Firstly, we have matplotlib. It is an open source library which we use for plotting and graphing different information. Secondly, we have pandas visualization. So we have studied pandas. We have seen that it can be used for data pre-processing of tabular data. It can be also used at the same time for visualizing that tabular data, which we'll see later on. And thirdly, we have Seaborn, which is another open source library of Python, and it has similar functions. So it's up to you whether you want to use either one of them, but each one of them has their pros and cons. So mostly we use them according to our problem. So it's better to have the sense and understanding of all these libraries whenever you're visualizing your data. So let's talk about matplotlib. It is a low-level library which gives us more extensive tools and power that we can use to plot our figures and manipulate much more visualization. So it gives us more power as compared to higher-level libraries that are more like interfaces. So this gives you the ability to change the functions in itself, and it is quite popular. Although it is difficult to learn, but it is still considered to be the most popular and strongest visualizing library today. So since it is low level, it gives us greater control. We can use different types of plotting functions and we can combine them and we can change them according to our preference. The coding is extensive. Like I said, low level languages, low level libraries, they are extensive in code. They are complex, they are difficult to learn, but they give us greater control. So there is a trade-off between complexity and the ease of learning. So it is quite similar to the MATLAB interface. There are a lot of functions in matplotlib that have the same name as the MATLAB functions. They are quite similar to it, and the graphing functions, even the plotting functions of it, are derived from the MATLAB interface. The next we have the pandas visualization. This is the most easiest interface you can use and the most quickly visualizing tool. If you want to have a quick visualization, pandas gives you that. And because most of the time you're using pandas to convert your data into and pre-process it, at the same time you can visualize it. Pandas serves as a dual functionality. You can do different things at the same time, so it actually increases your productivity. So pandas is built on matplotlib. In the lower level, the functions are still of the matplotlib, but the interface makes it easier. So it is better and preferred. If there is a lot of conventional visualizing of the data involved, then it is better to go with pandas instead of matplotlib. So it is a higher level API and it has less code. You just have to call some functions and so on. So thirdly, we have the Seaborn library. It is built also on matplotlib. It is integrated with pandas data structures. It is more powerful as compared to matplotlib and pandas. So when you're deciding between pandas and Seaborn lib, it becomes a rather tough choice because both of them are very powerful libraries. They come with integration with the data frames, so you can manipulate data frames along with visualizing them. So it gives us a concise control over matplotlib. Since matplotlib is extensive in code, it is difficult to learn. So when we will study the code of plotting using matplotlib, you will see that even a simple function will have at least 3 to 4 lines of code in order to successfully plot it. But if you're using Seaborn, it mostly takes 1 line of code and it covers all those 4 to 3 lines. So it gives us a very concise and comprehensive control over matplotlib. So we have studied types of data visualization in statistics. Let's go through them once more so that we can have a better understanding of what we're trying to visualize. Data visualization, we have 2 types, univariate, multivariate. Univariate further divided into numerical and categorical features, and multivariate we're taking 2 features against and plotting them against one another. We have numerical versus numerical, numerical versus categorical, and categorical versus categorical. So this is the hierarchy for data visualization, and which we're going to use to implement in Python. So the univariate visualization, we have 2 types, discrete and continuous. Univariate visualization, the plots for numerical features we have the frequency table and histograms, the density plots, and the box plots. So the frequency table, we need to summarize the data. We have studied it before. So if you want to consider the concept of the newly learned material, we can generate the frequency table using pandas, and if you can remember it, we have seen that using value counts. So the value counts gives us the information exactly similar to the frequency table. So you can use that pandas function, take 2 particular columns or 1 particular column and use it to get the frequency of those values. Then you can visualize it using histograms. So it gives us the frequency distribution. If you want to study one feature, a histogram is the values grouped into bins. And why do we use histograms? We know that the shape of the histogram tells us about the type of distribution, and that can give us a lot of information and insights about a particular feature, and will ultimately help us in feature engineering and pre-processing as well. So we have different types of distribution: bimodal, comb, edge peak, normal, skewed, and uniform. So mostly we're going to study bimodal, normal, skewed, and uniform. Bimodal, when we have 2 values who have about the same, or you can say high frequency as compared to 1 value. So that's why there are 2 peaks in this distribution. In the normal one, we have the bell-shaped curve. The information is concentrated in the middle, and then it spreads out on both sides. And skewed, the information is either on the left or right side, depending on the type of skew. And uniform, the information is spread all across the x-axis, and there is no dominant or prominent frequency of a particular value. So let's talk about density plots. We are using them for continuous variables. You can say it is a better version of a histogram because it gives us a smooth value. If we're talking about the night price distribution of Airbnb apartments, then this would be the density plot for that. So if you want to study distributions, it is considered to be a better option as compared to histograms. So we have the same distributions of these as well. The only difference is that instead of bins, we have continuous values. That's why we have these mountain-shaped peaks, although they represent the same information. So the box plot, is the most informative plot we have. It gives us the information of median, upper quartiles and lower quartiles, interquartile range, and outliers in a dataset. This is the box plot, and the anatomy of box plot, we have the 25th percentile on the left, 75th on the right, median in the middle line, encompassing the box. The outliers are represented by the dots. The range represents the minimum and maximum value. So the univariate visualization, when it comes to categorical features, we will study them independently and together as well. These are the values that you can say that if these values are ordered, then we call them ordinal. The particular type of a categorical feature in terms of binary, it only has 2 possible values. It's either true or false. And the categorical features have fixed set of values. They're all exclusive. They do not have any relationship with one another. And when we want to visualize these particular type of features, then we use the frequency table and bar plot. We have seen the frequency table, and we can use pandas to do that. For bar plot, it is going to come down to the visualization of the bars which do not have the exclusiveness can be identified in these bars using by the spaces between these bars. So the multivariate visualization, we're going to take two variables, we're going to visualize them, and we're going to visualize them against each other, and we have numerical versus numerical. The question is which plots would be best to compare to numerical features. So we have scatter plot and correlation matrix. Scatter plot is just the Cartesian coordinates of each value represented on a plane of x and y axis, and this can be used to plot it, and then we can further analyze it to identify patterns in this plot. The correlation matrix, we have studied the concept of correlation as well as covariance, and this particular matrix gives us both of these values. As you can see, there are negative values in this matrix. The negative value shows that the correlation is negative, which exhibits the negative or inverse relationship between the two features, and the stronger the correlation is, higher the value, and the negative or positive sign shows how strong or in which direction is this strength or relationship progressing. So we have seen the numerical versus numerical. Now we will talk about numerical versus categorical. For this we have two different plots, scatter plot and box plot. In scatter plot, we will use every category as an independent feature, and we will visualize it against the numerical features. So you can see the exclusiveness in this graph and the categories that are shown in the x-axis, and that can be presented over there as well. You can also say that you have about 4 scatter plots, each for different categories. And the exclusive nature is quite visible from here, but you can learn a lot, especially their relation with numerical data and their spread, whether this amount of data is sparse and how much it's concentrated in which direction, and you can learn from the progression as well. Now when we talk about box plot, we're going to extend the same concept over here. We will see that each and every category will have its own box plot against the numerical values, which are quite important, and you can also say that each category will have its independent box plot. So let's talk about categorical versus categorical. In this one we will be seeing side by side bar plots. So the same concept is also extended over here. Since each categories are exclusive in nature, they have set and fixed values, so the bar plot will be individual to every category, and they will be, the thing is we can visualize them in one plot, and we can also do a quick summary for them. So this is a quick and comprehensive way to summarize the plotting of categorical versus numerical data.